Let's look at the average rate of change as it applies to physics. Recall that we defined the average rate of change between x1 and x2 as we did the slope. That is, the change in y over change in x, which is y2 minus y1 divided by x2 minus x1. Let's also remind ourselves that the units for rate of change, average rate of change, and slope are all the same, which are the units of y over the units of x. Now let's look at our example. Suppose that the height of a calculator thrown into the air is given by s of t. The values of the height of s of t are given by the following table. When t equals 0, the calculator has just left our hand and is 4 feet in the air. After 1 second, it has traveled up to a height of 63 feet, and by 2 seconds, it is at a height of 90 feet. Once we get to 3 seconds, it has started to make its way back down to 85 feet, and after 4 seconds, it is down to 48 feet. Let's find the average rate of change of position with respect to time, which is called the average velocity, on each interval. Velocity keeps track of both speed and direction. In this example, a positive velocity means the speed going up, and a negative velocity means the speed going down. Let's continue with calculating the average velocity on each interval. First, we will calculate the average velocity between t equals 0 and t equals 1. To do this, we calculate our change in height, which is 63 minus 4, or 59 feet, divided by the change in time, which is 1 second that has passed. So we find that the average velocity is 59 feet per second. We calculate the average velocity between t equals 1 and t equals 2 similarly. We find the change in position, which is 90 feet minus 63 feet, or 27 feet, divided by the change in time, which again is 1 second. Doing this, we find that the average velocity is 27 feet per second. Between t equals 2 and t equals 3, the average velocity is negative 5 feet per second. And finally, in the last second, our average rate of change is negative 37 feet per second. Notice that in the first 2 seconds, our function is increasing, while in the last 2 seconds, our function is decreasing. It's also worth noting that because our average velocities are decreasing from 59 down to 27, all the way down to negative 37, our function is concave down.